Hello, my name is Juri Gambalevski, and this is my PeerWise project video solution. Here is a question I created during the project, which is on projectile motion. Looking at the question, the projectile starts at the top of a cliff at a height of 7 meters, which is here, with an unknown angle, which is theta, and the unknown velocity at point A, which is u, and an unknown velocity at B, which is labeled 3u. To begin solving part A, which asks us to do, using an energy method, find the value of u, we must use an energy method. Therefore, using SUVAT would be incorrect. The energy method we are going to be using will involve kinetic and gravitational potential energy. So, as we know, the ball starts at height and has an instantaneous velocity of u after launch, meaning there is both kinetic energy and gravitational potential energy acting together. We can write this down as Ke at point A plus G P E at point A, and leave an equal sign. As the projectile reaches its peak, it loses both kinetic energy and gravitational potential energy, which is here. When the projectile lands at point B, it only gains kinetic energy, as there is no stored energy for gravitational potential energy. This gives us Ke at point B. We then can write out the formulas, which is half mv squared plus mgh is equal to half mv squared, and then we can begin to substitute the values, which is half m bracket u squared, the brackets will be important later on, m, then gravity, and then the height which was given to us, which is 7, which is equal to half m and then 3u, as this is the point B side, and squared inside brackets. Then we can cancel out the common m variables, which is the mass, so this leaves us with u squared plus half u squared, and then g7 is equal to half 3u in brackets squared, and then we can square the coefficients of u, which will become half and then u squared, so this loses the brackets, then 7g, we can write it this way, and then half 9u squared, because we have to square both the coefficient and the variable. We then have to multiply the half to the coefficients, which will then make it 0.5u squared plus 7g, which is equal to 4.5u squared. We can then continue by rearranging to obtain u, which is simple, as we can minus both sides of the equation, which will be 7g is equal to 4.5u squared minus 0.5u squared. So now we've got two common variables here which we can minus. This leaves us with 7g is equal to 4u squared, and then we can rearrange and divide both sides by 4, which will leave us with u squared is equal to 7g over 4 square root as well, because now I want to get rid of this squared, which will leave us with u. This will give us then an answer of 4.14 meters per second in two significant figures, and that is part A done. Now let's look at part B. The time taken for the projectile to travel from point A to point B is 1.6 seconds. Find the value of theta in degrees. So first of all, we know straight away that t is equal to 1.6 seconds, and the acceleration due to gravity is minus 9.81. The way to start part B is by laying out all the SUVAT values which are known in order to identify which is the correct SUVAT equation to use. We solve vertically as the range is unknown. So, we can lay out the question by writing S, U, V, A, T. We know the vertical displacement, well, the total vertical displacement, as the projectile begins at point A, which is at 7 meters, and then falls below its start point, which means the vertical displacement will be -7. And then we use u sine theta for initial velocity, because we need to use the vertical component to find the angle. Then final velocity is not needed, and acceleration is known, and the time is known. Now, looking at the suitable SUVAT equations that we can use with the variables provided, we can clearly see that S is equal to ut plus half at squared is the best candidate. And then we can next substitute the values. So for S minus 7, and then u is 4.14, and then sine theta, because we're subbing in u sine theta. Put that in brackets, and then 1.6 seconds for the time, then plus half multiplied by the acceleration due to gravity, which is 9.81 negative, and then multiplied by 1.6 squared. We can then begin to break down the question, which can be done by leaving minus 7 here for now, and then 4.14 sine theta, and 1.6 here, and then we can solve this area here, which will give us minus 12.5568. We can then rearrange the minus 12 to the other side by minusing both sides by 12, which will then equal to 5.5568, which will equal to 4.14 sine theta, close bracket, 1.6. We can then divide both sides by 1.6, which will give us 3.473, which will then equal to 4.14 sine theta. And then we can divide by 4.14 on both sides, which will then give us 0.838 sine equal to sine theta. We can then inverse both sides by sine, which will equal to inverse sine, bracket open, 0.838, which will then give us our angle, which is 57.02 degrees, which is rounded to two significant figures. And that gives us our answer for part B. Finally, let's look at part C, which is find the horizontal range of the projectile, which is this distance, which can be done by first us finding the vertical component here and the horizontal component of the projectile at start point at point A. We can note this down as the horizontal point, which is u cos theta, and then the velocity at y, which is the vertical component, which is u sine theta. So then you can begin substituting in the values we got from the last answers, which is 4.14 cos 57.02 2 degrees, which will then give us 2.25 meters per second for the horizontal component, and then 4.14 sine 57.02, which will give us 3.47 meters per second. We can then proceed to use the horizontal range formula for when the projectile has a starting height. This can be noted down as x, so this would be x, the range, and then you write Vx, then open bracket, Vy over G plus square root of Vy squared plus 2gh over G, and then close bracket, and then close it again. So this will be the formula that we substitute all of our values in. So then we begin substituting Vx, which we got up here, which is 2.25, which is then multiplied by open bracket, Vy, which is 3.47, over G, which is 9.81, plus the square root of Vy, 3.47 squared, here, close bracket, plus 2 times 9.81, which is the gravity, times the height, which is 7 meters, over gravity, which is 9.81. Close this all in brackets, and then close it off there. We can then begin to break down the question. So we can leave 2.25 as it is, and then we can find out what 3.47 over 9.81 is, which is 0.3537 plus, don't forget to add this side of the formula, which is 1.2459, and close bracket. So then we can find the final answer, but put this through the calculator, which is 3.5991 meters, and then round off to two significant figures, which is 3.60 meters. And note that it is two significant figures. And that's it. That is the end of the tutorial.